Good morning and welcome to Chapter 2, Section 1. We are solving equations in Chapter 2, at least the first half of it. And Section 1 deals with solving equations using addition and subtraction. We're going to start with a little bit of vocabulary. An equation is a math sentence with an equal sign. If it doesn't have an equal sign, it's not an equation. It's just a numerical expression. To find the solution of the equation, which means what does x equal, you have to get only the variable on one side of the equation, on one side of the equal sign. For example, we have x plus 6 equals 11. How do I know what x equals? I have to get x by itself on this side of the equal sign. Get the x alone. Now, how do I do that? There's a 6 added to that x. And in order to get rid of this plus 6, I have to do the opposite of this, which is minus 6. But I have to subtract 6 from both sides of the equation. This is what keeps it equal. It has to be an equation. We have to do the equal things to both sides. So if I subtract 6 here and I subtract 6 here, this goes away. And I bring down my x on this side, I bring down my equal sign here, and I do this math. 11 minus 6 equals 5. I would like to see you write out the equation and then set it up like a giant addition subtraction problem so that you can keep track of complicated problems. These are going to get complicated pretty quickly. And we're going to have to track things, and you're going to want to do math quickly because nobody wants to spend a whole bunch of time doing math. So please set it up so that you can see everything easily. So let's do a few problems to practice this. Right now, our first example, I've got x minus 10 equals 4. I have a 10 subtracted from my x. I have to get my x by itself. I have to do the opposite of this to get rid of this so that my x is by itself. So I'm going to add 10 to this side, and if I add 10 to this side, I have to add 10 to this side. I make it a giant problem. I know that this goes away, and I have x equals, and now it's very easy to do the math. I can see it easily. Next, I have 2/5 equals m minus 1/5. I have 1/5 subtracted from my m. To get m by itself, I'm going to add 1/5 to both sides. Luckily, it's given me common denominators, so I can do this in my head. Our next example, x plus 7 equals 9. I have a 7 added to my x. To get x by itself, I'm going to do the opposite. And I'm going to do it to both sides so that that goes away, and I have x equals, and 9 minus 7 is 2. 0.7 equals r plus 0.4. I have a 0.4 added to my r. I'm going to subtract 0.4 from both sides to make this go away and put my variable all by itself. I'm going to do this math, and r equals 0.3. I have a negative 8 added to my b to equal 2. Now, it's added to my b, but it's a negative 8. I have to do the opposite of this to get rid of this. And the opposite of negative 8 is positive 8. I have to add 8 to both sides in order for this to go away. It's not the fact that it's added, it's that this is a negative 8, and I have to do the opposite. So please remember that. That will mess you up. I'm going to bring my b down, and b equals 10. Now let's check that to make sure. Does negative 8 plus 10 equal 2? Is that true? Yeah, that's true. Putting your answer back in the problem to check it is a good way to get a really good grade on a test. So please remember to check your answers if you have any questions. Okay? I'd like to ask you to do the check it out problems, numbers 1, 2, and 3. Push pause and come back. Our check it out problems for number 1, n equals 8.8. K equals 0 and m equals 25. For check it out 2, d equals 1/2, k equals -10, t equals 8. If you have any questions about these, please ask me. And 3, m equals 9.3, z equals 2 8/4, and x equals 44. Next, we have a word problem on top of page 79. Maximum heart rate is the highest rate in beats per minute that a person's heart should reach. What they say is that your age is added to your maximum heart rate, and that total should be 220. So the older you get, the lower your maximum heart rate should be. So the question is, what's the maximum heart rate for your average 15-year-old? What if we substituted 15 for age? So 15 plus r is 220, and what I want to find out is what's the maximum rate. I want to solve for r. I have to get r by itself, so I'm going to subtract 15 from both sides, and I'm going to get a maximum heart rate of 205 beats per minute. So go ahead and do the check it out on page 79, check it out number 4. Do that now, push pause. So if our maximum heart rate is 125, the question is how old are we? So we subtracted 185 from both sides to get a by itself, and that is the maximum heart rate for your average 35-year-old. So we have a couple more vocabulary pieces. The addition property of equality means you can add the same number to both sides of an equation and it will still be true. And we've been doing that to get negative numbers away from our variable. The subtraction property of equality is the same thing except for subtraction. So you can either add or subtract the same number from both sides of the equation. As long as you do it the same, then it's still going to be true. And that's all we have for section 1. Your homework today is page 80, numbers 21 to 50. See you tomorrow.